Okay, welcome to our first lesson in discrete functions. So we're going to be talking about arithmetic and geometric sequences. So the learning goal today is to look at the relationship between sequences and discrete functions so that we can create and use formulas for sequences. So we'll have to learn what discrete functions mean. So success criteria are, I can determine if a sequence is arithmetic or geometric. I can write the general term so that I can use it to find other terms in the sequence. So really that's just like using the formula. The general term is a fancy word that we use to say any term in general, but really the formula. And then I can make connections between linear and exponential and the arithmetic and geometric. So for the following pattern, what would be the 100th number? So there's a few ways you can think about this question. So you can pause the video and try this out for yourself. After you've looked at it for a bit, like you would actually realize that you're adding 5 each time. So you can think about what it would look like to add 5 each time or add 5 to get the 100th number. Now the question is, do you add 5 100 times, or do you add 5 99 times or 101 times? Like that's really what matters. So definition, a sequence is an ordered list of numbers. Each number is called a term. And we use subscripts to identify the position number. So term T1 is term 1, T2 is term 2. So 3, 6, 9, that's a sequence. The first term is 3, so T1 is 3. Second term is 6, so T2 is 6. And the third term is 9, so T3 is 9. And then T4 would be 12, etc. So a couple of reasons why we're kind of exposing you to like a different notation at this point in the course, just to see things differently. You've seen this before. You've seen subscripts before when we describe the slope where like x2 minus x1 or y2 minus y1 over x2 minus x1. So we've seen subscripts before, but the sequence is going to be a term. And so like on the warm-up, like you saw another example of a sequence. General term is a formula, so it's Tn, so any term, that expresses each term in the sequence as a function of its position in the sequence. I don't think that's the proper use of it. For the sequence 3, 6, 9, the general term would be 3n because you can just multiply by everything by 3. Using the general term, we can say that T20 would be 3 times 20, so we get 60. A general term is really powerful because you can just plug in a number and you can get that term. Discrete functions are really like the domain is n equals 1, 2, 3. It's just the counting numbers. The range is all the terms in the sequence, and those could be anything. But why they're discrete, similar to why we use integers when we talked about domain and range, is that there's only values on the whole numbers. Discrete numbers are things that are obtained by counting, and so continuous are measured. Measuring allows you to have infinite points between any two values. Discrete data is different in that there's no points between. So you can't have term 1.3 or term 1.9. There's only term 1, term 2, and nothing in between. These are arithmetic sequences, so you can kind of look at what an arithmetic sequence is. This is pronounced arithmetic, not arithmetic, because it is an adjective describing a sequence. So we can look at each of these relationships and ask yourself, what's the pattern? So in an arithmetic sequence, the difference between consecutive terms is the same. So in the first one, we call it D. D is 4. Second one, D is 10. And the third one, D is minus 3 because it's going down. This is very similar to the slope in a linear equation. An arithmetic sequence looks like this. So the first term is A. The second term is A plus D. And the third term is A plus 2D. And so by this kind of format, we can actually create a general term that says any term is A plus 1 less than the term number. So term 4 would have a 3 here. 4 minus 1 times D, which is the common difference. This is very similar to the equation y equals mx plus b. B would be the y-intercept, and D would be the slope. But there is a transformation that's happening here. Because the first value when we think about lines and slopes, the first value is actually the y-intercept. but we don't have a term 0. We don't want to talk about term 0. We want to talk about the first term as term 1. And so what happens here is we just shift things to the right one. So this is a linear equation that would have gone through like this y-intercept of a, but then it's just shifted to the right one, and that's where the minus 1 is. And so it's very, very similar to the form y equals mx plus b. You can see that those are identically the same. Given the sequence 4, 7, 10, find the 35th term in the sequence. So you can set up an equation. We know a is 4, d is 3, and n is 35. So we can use that formula, a plus n minus 1 times d, to find out the 35th term is 106. Is 94 a term in the sequence? Well, we can try to sub it in and see what happens. Subtract 4 from both sides, divide both sides by 33. Add 1 to both sides, we get 31. So yeah, it's the 31st term. Think about, like, how would you know if it's a term or not? And remember that, like, we can only have counting numbers here. We can only have whole numbers. So if you got a decimal for n, it wouldn't be a term.